Hello, fellow scientists. This year for STEMfest, I'm going to talk about rocket science. That's right, rocket science. I'm going to explain the fundamental concepts of rocketry and demonstrate these concepts by building a water rocket and test stand assembly. And then we'll conduct a few launches.
In rocketry, there are four forces that act on a rocket. They are lift, drag, thrust, and weight. Lift is an aerodynamic force which is important for airplanes but relatively small in rocketry. Drag is an aerodynamic force that opposes motion. The thrust force acts upon the longitudinal axis of the rocket to propel the rocket. Weight acts through the rocket's center of gravity towards Earth. Since I am launching my rocket vertically, I will neglect lift force. This leaves us with three forces. I'll explain these as we go along.
We're using a 2-liter bottle as our pressure chamber that holds the propellant, in this case water, and the pressurized gas, in this case air. The opening of the bottle acts as the throat of the rocket.
Going back to our equations, drag depends on the density of the air, velocity of the rocket squared, the cross-sectional area of the rocket, and the coefficient of drag, which depends on the shape of the rocket. For example, my coefficient of drag will be less if I use a cone-shaped nose, and will be greater if I have a blunt, flat surface.
We're cutting off the end of a second 2-liter bottle to create my nose cone.
For flight stability, the center of gravity must be above the center of pressure.
I have cut the other end off of the nose cone, and I'm now using my little sister's Play-Doh as ballast at the top of my rocket for stability.
We can reduce weight by using lightweight components to minimize mass. Alternatively, we can launch from a location with a smaller gravitational acceleration, such as the moon. Unfortunately, that is beyond my scientific and financial capabilities at this time. To minimize the mass of my rocket, I constructed the fins out of lightweight plastic, and affixed them to a plastic skirt using the engineer's favorite, duct tape.
We are constructing our launcher out of Schedule 40 PVC pipe. The base will be at right angles for support. Safety first. After we have cut our PVC pipe, we will use glue and primer to attach the pieces together.
Here's our finished product, ready for launch. Thrust depends on the propellant mass flow rate and the exit velocity. Assuming incompressible, the mass flow rate depends on the density of propellant, in this case water, the exit velocity, and the exit area. It's important to note that I could use compressed air only. However, water is nearly 1,000 times more dense than air. With a greater propellant density, the mass flow rate is greater, thus the thrust is greater. The exit velocity is a function of chamber pressure. The calculation is beyond my scope, but to simplify, if I increase the chamber pressure, I increase the exit velocity. Thus, the thrust will increase. Test number 1, pressure test at 30 psi.
Blast off!
Or not.
Test number 2, 60 psi, 800 milliliters of water.
Stop!
Test number 3. 80 psi, 800 milliliters of water.
Blast off! Blast off!
Final test at 100 psi, 800 milliliters of water. Be aware that the burst pressure of a 2-liter bottle is approximately 150 psi.
1, launch. 1, 1, launch. Thank God that didn't hit my car.
Thanks for watching my video on soaking wet science. See you next year.